Hi everyone, I'm Yuntao Wang from CS Department of Tsinghua University. Here I present a new task entry method on smartphones with QWERTY keyboard for users with Parkinson's disease. This work is a collaboration between Tsinghua University and the University of Washington. As the world population's average age increases, Parkinson's disease has become a challenge for more and more people. In 2020, the number of Parkinson's patients reached 10 million. Parkinson's disease is a long-term nervous system disorder that mainly affects the motor system. The most common symptoms are hand tremor and muscle stiffness. These symptoms significantly affect the user's daily living. Among all the daily tasks, interacting with touchscreen phones is a major challenge for users with Parkinson's disease. Task entry is the hardest task according to a study by previous research. To solve this problem, previous work proposed many keyboard solutions. I listed a few on these slides. However, they either targeted on beginners or required interface layout modification, causing users to face a steep learning curve. This paper instead focuses on the touch-based software QWERTY keyboard among experienced Parkinson users, the most dominant task entry method on smartphones, according to a user survey. The basic idea here is to leverage statistical decoding methods to predict the targeted word the user wants to input. This is achieved by combining the touch model and the language model. Classical statistical decoding algorithms are good at correcting substitution and transposition errors, but not the omission or insertion errors, which are two common typing errors among users with hand tremor. Therefore, we proposed a new method using elastic probabilistic model. The model considers all types of typing errors using both spatial and temporal features. To achieve this, we first conducted a user survey to explore the most widely used layout and typing posture in daily scenario. Results show that 13 out of 16 participants used the QWERTY keyboard on their smartphones and then preferred one index finger typing the most. Then we conducted a second user study to model the typing behavior of users with Parkinson's disease. We also investigated and compared the different typing behavior between Parkinson's users and young adults. Results show that experienced Parkinson's users can type at a speed of 19.8 words per minute, which is much higher than previous study on inexperienced Parkinson's users. Obviously, users with Parkinson's disease made significantly more typing errors. We also observed important temporal features among users with Parkinson's disease. Most of the unintentional touches caused by the hand tremor made a distinguishable distribution away from the regular touches. We built the touch model of users with Parkinson's disease. We observed significant large touch point spread and offset in both X and Y directions. Finally, we implemented our elastic probabilistic model that generalizes the classical statistical decoding algorithm to correct all major types of errors. This is achieved by incorporating both spatial and temporal features. To evaluate the effectiveness of our method, we conducted a user evaluation study with 8 participants with Parkinson's disease. We benchmarked 2 elastic probabilistic model-based autocorrection methods against the 2 baseline methods that are basic language model and elastic pattern matching. Results show that the dynamic elastic probabilistic model can achieve 22 words per minute typing speed, which is significantly better than the baseline methods. Also, the dynamic elastic probabilistic model also have significantly lower word level typing error rate and a character level typing error rate than the baseline methods. In addition, elastic probabilistic model-based methods has less keystrokes per character and time interval between touches. User feedback study indicated that users prefer our method over baseline methods, significantly considering perceived accuracy, speed, correction, confidence, and overall preference. To summarize, we built and analyzed the touch model of experienced Parkinson's users on the software QWERTY keyboard, including both temporal and spatial features. We proposed a smartphone QWERTY keyboard for users with Parkinson's disease based on elastic probabilistic model. We proved the high task entry performance and the usability of our method against the baselines through an in-lab controlled user evaluation study. Please look at our paper for more details. Thanks for watching.